Um, so there are some trends that we observed in the last few years in the industry. First of all, from the tooling perspective, when it comes to data analysis and data science, I think if you work in data analytics, you must know Python or R. So data frames, right? The most well-known package for data manipulation in the Python ecosystem is probably Pandas. And Pandas is really good for analyzing smaller amounts of data. So it assumes that the data frame can fit into memory, and then you will do all the data transformations using Python and Pandas. So the data is probably a couple of 100 MB. It could be 1 gig or 2 gig or 5 gig, but going beyond that, unless you have a very powerful workstation or server, it's going to be kind of slow, right? And of course, Apache Spark has been around for many years, and Databricks is doing really well in the enterprise space and even in the open source community as well. A lot of companies start to adopt Apache Spark. In the past, I think Hadoop and MapReduce has been, really, dominant in terms of distributed computing. But Spark is definitely, pretty much this king of big data distributed computation. So when you have massive amounts of data, then Apache Spark is a really good choice. But the industry is also shifting, right? Some companies would prefer to do ELT. So a lot of the data engineering stuff is done in Snowflake, for example, right? I've also worked with clients that are just reevaluating Apache Spark and doing some benchmark against tools like Redshift or Snowflake. And of course, Spark can do more, right? More than just SQL and databases. You can use that for natural language processing. You can use that for streaming data analysis. But just from a data processing perspective, there are also some other alternatives, right? But we use Spark when we have really big data needs. What about a data size that's in between, right? So you have like 20 gig, 50 gig. Using Apache Spark might be an overkill, right? Especially when you're running things on-prem, then it's probably not worth it to have a Spark cluster, because I think the data engineer or just even setting up this Spark cluster is a lot of pain. So maybe you can consider another popular framework, which is called Dask. Dask is getting kind of popular, and I used it a couple of times, and it's pretty good. You can think of it as a distributed version of Pandas. Yeah, I just want you to know some of the options out there. Give Dask a try, and it's pretty awesome. It can be deployed as a distributed compute engine similar to Spark, because it has this lazy execution kind of style as well. So this is from tooling perspective. AutoML is also happening, right? There are a lot of open source projects out there that does AutoML. There's some of these, such as Data Robot, H2O.ai. H2O.ai, they have their, it has its open source version, but they also have the, enterprise version that they have to pay for. So I think that with AutoML, it's not going to completely replace the data scientist job, right? But it allows data scientists to do quick prototype. For example, I haven't seen many companies using complete, AutoML solutions in production. And you obviously will need, data scientists still to fine tune your algorithms. But getting something, done quick, really quickly, AutoML is a really good option. There are also packages such as PyCaret, which is getting really popular in the past few months. Model explainability is getting important. Right? If you have some experience with machine learning, you know that if we use decision tree-related algorithms, tree-based algorithms, then they have this built-in global interpreter. You can use the variable importance in random forest algorithm, for example, to explain the important variables. But there are some other packages that allows you to do local interpretation, such as Lime. So just keep that in mind, I guess. Feature engineering is really important. There are projects out there such as feature tools that allows you to, sort of like, automate this feature engineering process. But that's not the ML feature engineering, right? It's really just the data preparation for machine learning. But some other companies are also trying to adopt, feature to, feature tools such as, Feast. which is it comes in handy when you want to deploy your machine learning models in production, and you need a production grade, feature store. And feature tools and feature store are, also getting popular. Now, on the model deployment side, right, deployment, model serving in the cloud, and how do you orchestrate your ML pipeline? There's some really great options out there. For example, Amazon SageMaker, Azure ML services, or Kubeflow is another alternative here. They all have their strengths and weaknesses, but SageMaker is widely popular right now. We covered SageMaker, I think, 3 days ago. So I'm not sure if you were in that session, but if you're not, we will share the recording on the website as well, so you can check it out. But SageMaker is this platform as a service provided by Amazon Web Services that allows you to to label your data and do model development on a training notebook instance, and also you can do large scale distributed model training and model tuning as well. Using SageMaker algorithms, but you can also bring your own containers, your own solutions, and deploy them as endpoint in SageMaker. Sort of remove the needs of of DevOps or ML engineer, but in production, in practice, it's probably impossible. So there are teams that are small scale teams that maybe they have lots of data scientists, but they don't have the software engineers to help them put things into production. I find that in that kind of situation, using SageMaker will make a lot of sense, because you don't have to worry too much about hiring DevOps person and ML engineers to help you deploy things. But I think if you have a relatively larger team, you probably want to hire ML engineers, data engineers, data scientists to all work in a team, and the ML engineers will focus more on the model pipeline automation, how to scale your machine learning algorithm training, and also how to deploy and serve the machine learning models in production. So SageMaker is a good option, and they recently also released the features for building ML feature pipelines, which is pretty cool. They also have the SageMaker Studio that allows you to do code-free, machine learning stuff. So definitely check it out. There's some other trends, so on the, I think infrastructure and, orchestration side, Kubernetes is getting very popular. So I think I have another slide that explains that. But so basically, sorry, I'm just trying to let some in. On the left-hand side, you will see, the resource managers. So if your company use a Hadoop cluster or running a Spark cluster, Apache Yarn is a pretty popular resource management tool. It allows you to manage different workloads and manage different users who share the same cluster. And Kubernetes is another way to do that. So everything is containerized, and I think the since Spark 2.4, it already starts to support Kubernetes, and there's we start to see more companies running Spark in Kubernetes in production. But the good thing about Kubernetes is that it doesn't have to be Java based, right? So in the Yarn ecosystem, right, Hadoop, Spark, most of these are written in JVM based languages, so it works well in that ecosystem. But what if your companies want to run Python-based applications, running Flask applications, or maybe you want to use Jupyter Notebook in a cluster? So traditionally, that has to be separated from your Hadoop and Spark cluster, right? You have to maintain separate infrastructure. But with Kubernetes, it doesn't really care because everything is containerized, right? You can run all kinds of workload. So I don't think a data scientist need to be expert in Kubernetes and how to maintain this kind of infrastructure, but knowing how to work with some of the tools such as Kubeflow can be useful. Kubeflow is the ML pipeline platform running on Kubernetes. It was a tool built at Google, but the basic idea is that if you look at the whole ML pipeline in production, it is more than just writing your machine learning code in Jupyter Notebook or in Python script. And so there are a lot of things you need to do, such as data verification. Make sure that you always have the right data that feed into the prediction engine. How to do feature engineering, how to build the serving infrastructure so that you can do scalable predictions, and how do you monitor the performance of your machine learning models in production. How do you detect feature drift? Kubeflow is one of the tools out there that can that helps you achieve that goal, and it runs on Kubernetes. So that's also one of the limitations, I guess. If your company runs everything on-prem, it's and it's a little bit challenging to run Kubeflow unless you have an on-prem Kubernetes cluster. Now let's take a look at this, big data ecosystem. So we're talking about how to build portfolio, big data project portfolio. So our focus will still be a little bit more on the data analytics side instead of like machine learning. So we'll be focusing on how to use Apache Spark, how to work with Hadoop, and how to build an end-to-end data pipeline. But let's try to understand, what's required, right, to build a big data project from a company perspective, and we'll try to adopt that for our personal project. So to work with big data, I think you need to have infrastructure first. A couple of years ago, you can find a lot of tutorials on how to set up a Hadoop cluster, on your laptop, right? But people rarely do that anymore because, with AWS and GCP becoming popular, it's very easy for you to set up a Hadoop cluster, run it in the cloud, and you just pay as you go. So the cost of launching something, for prototyping is getting much lower. That's probably another reason why some companies are jumping onto the cloud, because it's just companies can move a lot faster and have more agility. So you have to pick one, cloud providers, I guess, right? If it's for your personal project, I highly recommend that you deploy or run that in the cloud. So you can also show the employers, that you know how to work with cloud. You don't really have to be a solution architect, but it would be great if you can show some experience of working with some of the managed services in the cloud, like Amazon EC2 instances, how to work with storage, such as S3, how to launch a Hadoop cluster using EMR, and things like that. We'll talk about that, in our use case. And next step, of course, you need to decide where to store your data. Right? You can store data in the database directly, or if we're talking about big data, then you may want to have, a blob storage or Amazon object store. So to host your your data lake, right? So while you're building your personal project, of course, you usually don't have big data. So you either have to find a big data set out there, or you collect your own data. So if you're collecting your own data, like this is really just for personal portfolio project for job search purpose. So you don't really need to collect terabytes of data, right? But I think it will be more useful if you can just demo the whole end-to-end experience. Adding the data ingestion, I think can be really helpful. So if you're ingesting data, then you have to decide, are you ingesting data into Amazon S3 buckets, or are you ingesting the data into, for example, a NoSQL database such as DynamoDB or MongoDB, right? Or maybe a relational database. There's no right or wrong answer. It depends on what you want to achieve. So we'll talk about that in shortly. Okay, but let's say the companies that are moving to the cloud, right? So they're moving from on-prem to the cloud. So they have to decide, the data lake. First of all, you need to move all files, right, to Amazon S3, or companies can still run Hadoop clusters in the cloud, right, on EMR, or they built their own based on EC2 instances or using Cloudera, for example. But there are also database migration. So if you run, let's say, MySQL or SQL Server on-prem, you probably need to know how to do data migration to the cloud. And Amazon Web Services, for example, provide tools such as SCT, which is for schema migration, right? So you basically have to do some sort of mapping between your on-prem SQL Server database and, let's say, the Redshift data warehouse in the cloud. And then you'll have to transfer data to the cloud. it's probably not necessary, if it's a data science, big data project. But just so you know that this is, this is an option. But I think it will be more exciting just to collect your own data through web scraping or reading data from API and ingest that into Amazon S3 or a database somewhere. And next, you need to set up your Hadoop cluster or Spark cluster, and then you have to work with or choose a resource manager. So if you install Spark and Hadoop on Amazon, AWS using EMR, it's a managed service, so you don't really need to worry about setting up things like Yarn. It comes with EMR. But I added here so that you understand that in a typical enterprise environment, you're not the only one who's using the Spark cluster. It's shared across the entire organization or a bunch of teams. So you're sharing the cluster resource with other people, and that's why you need this kind of resource negotiator. Or if your company, is running everything on Kubernetes, you need to at least, know how to work with it. Or you don't need to be the expert in deploying Kubernetes, services and applications. Then we move on to the compute component, right? So now we have data, let's say assume big data stored in the cloud, in S3, in a database. How do we analyze the data? How do we transform the data? You have to choose a framework. And of course, we can use Python, Pandas, and so you can work with, the AP, like using, for example, using SQL Alchemy to read data from, from MySQL database. But still, everything needs to be read into the Python environment, running on a server somewhere. So it's not a very scalable solution. So that's why you probably need to consider a distributed computing framework. And MapReduce is one such framework based, which is part of Hadoop. But I think it's used when companies have lots of data. So I think using Spark as a compute engine is probably easier to get started. And MapReduce, is phasing out, right? So it's, for some companies, probably just a legacy system. It's it's still one of the really great tools out there, but just for compute, I think companies would prefer frameworks such as Apache Spark or Apache Flink. And Hadoop is still around because of the distributed file system, the yellow elephant, right? HDFS. So when you have petabyte scaled data, Hadoop still is a really good option to store large amounts of data. Plus, if a lot of companies are still not really in the cloud yet, so they will definitely go with Hadoop as a good option. In the Hadoop ecosystem, if everything is based on MapReduce, then you have a couple of options, right? Using Apache Hive, so which is SQL based. Hive is not a relational database engine, even though it has the SQL support, right? So, but when you submit Hive queries, it is broken down into MapReduce jobs. So Hive is this, this project, right? Basically a jar file that helps you to decompose your Hive queries into Java MapReduce jobs, so you don't have to work with Java MapReduce, right? And Apache Pig is probably not very popular anymore. There are companies like Netflix and LinkedIn that used to use Pig a lot, but Apache Spark is definitely more dominant. So I wouldn't recommend someone learning Pig anymore. And yeah, it's a different language and that you have to learn. And Spark is considered more as a unified compute engine. So definitely go with Spark. Mahout is, or some people say Mahout, that's the machine learning framework based on MapReduce, which is not popular, and we'll definitely stick with Apache Spark. In the big data ecosystem, there are also some other projects, such as Presto, Kyling. Presto was open sourced by Facebook, right? So it's pretty popular. There's a commercial company called Starbust, which is based on Presto engine. It's quite popular, and Amazon also, put that into their Athena offering. So Athena service, which is the serverless compute, service in AWS. It's based on the Presto engine. It's not MapReduce based, even though you still have this MapReduce compute style. And it allows you to run fast and scalable queries, so which is pretty cool. But I think as a user, you still mainly just write SQL, right? So it's not that hard to work with these tools, and it's the tools itself themselves are really powerful. Now, on the right-hand side is the Spark, family. Right? Spark is based on the Spark core. At its core, Spark is this, uses this RDD, resilient distributed data set concept. You can think of it as a distributed version of HDFS in Hadoop. Right? So it leverages in-memory computing better. You can do caching. There are a lot of optimization done at the data frame layer. So if you use Python or R or Scala, as long as you stick with the Spark data frame functions or methods, it is actually quite efficient. But of course, if you want to write user-defined functions, it will slow you down a little bit if you use PySpark instead of Scala. The good thing about Spark is that it tried to unify the APIs at the data frame level. So Spark ML is based on data frame structure streaming. Right? It used to be called Spark streaming, which is RDD based, but now it's data frame based as well. So it's a lot easier to write Spark jobs compared to Java MapReduce. So just a quick introduction to some of the tools in the big data ecosystem. Not everything is included on this list because otherwise the list will be pretty massive. But I think for you to build your own big data project, it will be really interesting project if you can include things like one of the cloud providers, right? You're building a project on Amazon or on Google GCP, and you're maybe using Spark Data Frame for data processing, Spark ML for machine learning, and of course there are things like TensorFlow that you can add here if you're interested in building deep learning models. But these are all batch processing, right? So an interesting project would probably involve some data ingestion and real-time inference as well. So you can consider either building your own, endpoint or model serving framework, model serving using tools like SageMaker, or if you have lots of streaming data coming in, maybe consider deploying your Spark models and do the real-time inference using Spark structured streaming. So these are some of the tools that I mentioned. We can go through one example shortly. All right, let's move on. So some of the other trend, for example, on the infrastructure side, a lot of companies are moving from on-prem to cloud. So doing migration. Data encryption and security obviously very important. How do you control access, right? Do identity and access management, and also infrastructure as code. Sorry about the typo. It's infrastructure as code. So using tools such as Terraform, but these are not necessarily data science skills. But just keep that in mind. I think you work in a data team, so you need to know some of these concepts as a data scientist. And at the storage level, I guess just as a quick summary, HDFS, I think it's losing its appeal gradually. A lot of companies are just choosing, Amazon S3 or blob storage in Azure for their, for the storage layer in their data lake. And one of the reasons is that it has, a lot of transparency in pricing. So you know exactly how you spent your money and where you spent your money. And on the orchestration layer or resource management, I think CloudData and Hortonworks, right, two of the big players in the Hadoop space, they merged as one company. CloudData, stock price is actually still increasing, which is actually good to see. But on the other side, I think Kubernetes is definitely taking over, becoming more and more popular. So running Spark workloads on Kubernetes is sort of trendy right now, and because it also supports non-Java based applications. On the computing side, I think MapReduce, right, and the Hadoop MapReduce is probably dying, but the MapReduce, right, this framework is still pretty popular because Spark is still based on the MapReduce concept, and SQL is well supported in the big data ecosystem. So Spark has Spark SQL. Presto is based on SQL and Apache Hive. So you start to see really great SQL support in the big data ecosystem, because many years ago you still need to know Java in order to work with Hadoop. But now you can just write SQL to manipulate large data sets. Serverless has also become very important, become kind of popular. For example, you can deploy your machine learning models or some of the data transformation steps using serverless functions. Starting to see some companies actually writing blog posts, discussing how they actually built entire data pipelines based on the serverless framework, which is kind of interesting. And the big data processing engine, like the tools are evolving, all the time. So my personal experience, when I joined the data space, started to work, as a data scientist many years ago, I was a SAS programmer. I was using SAS as one of the most popular, enterprise analytics tool. You can use SAS to do data processing, manipulation. SAS has, BI tools. It supports ETL, but most well-known, tools in the SAS ecosystem is it's, SAS, programming tool, and also SAS Enterprise Miner for machine learning and predictive modeling. So I use that a lot, and of course, and then I had to switch from SAS to Hadoop, back in 2011 when I was working on a big data project, and we tried SAS first, and it wasn't, fast enough, and I couldn't process really large amounts of data, and then we chose Hadoop, right? And it took me a while to get used to Java programming and writing, MapReduce jobs, and moved on to Hive and Pig as well. But of course, not a lot of people use MapReduce, Hadoop MapReduce, and Pig anymore. Spark is very popular. If you want to become a data scientist in North America, I think you definitely need to learn some Spark programming. Maybe you just need to focus on the PySpark side, because companies are definitely open to PySpark instead of Scala, especially on the data science side. And SAS is actually also evolving really rapidly, right? So they know the limitation of running everything in SAS, because you have to learn the SAS programming before you can do anything meaningful in SAS ecosystem. But they recently, I think since 2017 or 16, they released SAS Via, which is really great platform. So it runs on Kubernetes. It can run on-prem as well, and they embraced R and Python, because a lot of these can run in containers, and the SAS engine is kind of similar to the Spark engine, but it's closed. It's not open source. But it helps them to retain a lot of the enterprise customers, because we do both SAS and Python training, and we can see that a lot of organizations, SAS organizations, organizations that use SAS, they're thinking about switching to Python and R and open source, but there's also always that inertia, and people are reluctant to make changes. Even after we provide the Python training, they still need to make a decision whether they want to jump onto the open source side. So it will take years for some of those large organizations to adapt to open source. On the database side, whether it's SQL or NoSQL, I think it's interesting. I think I used to work with Oracle a lot, right? But mainly using like pulling data from Oracle using SQL. So I wouldn't say I'm expert in Oracle solutions, but as a data scientist, I think we just need to know how to retrieve data and extract data, and then we process the data either in the SAS environment or using Python or Spark, right? Redshift is Amazon's data warehouse solution. I should probably add some other database engines such as Google's BigQuery, and also, of course, Snowflake is getting really popular nowadays. But these are relational database or data warehouse solutions. On the NoSQL side, Amazon and Google published the papers on NoSQL technologies. I think in the same year. It probably dates back to 2003. Google created Bigtable, still around today. It allows you to process massive amounts of data, store massive amounts of data, and run queries, in parallel, very efficiently. In Amazon Dynamo paper, it came out in the same year, and it turned into DynamoDB, which is Amazon's own managed NoSQL database. And I think the Cassandra technology is sort of getting this inspiration from Dynamo. And in the Hadoop ecosystem, HBase is based on the big table idea, because Hadoop MapReduce is heavily influenced by Google's MapReduce paper. And so in the NoSQL world, Cassandra, MongoDB, these are popular column family or key value stores. But also there's some other NoSQL databases such as Elasticsearch, which is good for search engine and also log analysis. So I'm mentioning a lot of tools here. It doesn't mean that to get a data scientist job, you need to be expert in these. I'm really just talking about some of the evolutions here. I think to make an interesting big data project, you should probably have one of these databases in your project. It could be a relational database such as Amazon Redshift or using Snowflake, but it could also be doing real-time visualizations using Kibana and Elasticsearch, right? So if you're analyzing Twitter data, for example. So we'll talk about that shortly, okay? And on the SQL side, SQL on Hadoop or in the cloud, Presto, as I said, is getting very popular. But using Presto is pretty straightforward because you're writing SQL. But I think one unique thing about Presto is that it allows you to run queries to manipulate data from different sources, right? Because it has this really robust data connectors. So imagine you're joining a bunch of tables, and one data set is coming from a MySQL database, and you have data coming from HDFS stored in, the metadata is stored in Hive. There's a table from Cassandra database, and you can join the three tables. And so it's pretty flexible. And so you don't really have to move all the data into the same database or the same environment. So I think that's something that makes Presto really cool. And Impala is an alternative, and Cloudera used to push Impala pretty, push this technology, and it's in a lot of the benchmark. Impala does show better performance, but I think Presto is more popular in the industry right now. So one of the use cases for on the data analytics or BI side is building dashboard, right? But it's not really using Tableau and build dashboard, because whenever you build dashboard, you need to prepare data. So in some organizations, data preparation is handled by data engineers or ETL specialists or BI developers, right? But we're talking about big data in this case. On the top, you'll see the traditional pipeline. You have large amounts of data stored in Hadoop. You're going to pull the data, run some transformations in Hive or using MapReduce basically. And we're assuming you're dealing with large amounts of data, so it's going to take some time, right? And you're going to refresh the data and store a smaller amount of data in your whatever reporting database. It could be MySQL, PostgreSQL, or Redshift. And then you can, there's a built-in connectors from Tableau to read data from your SQL engine, and then pull the numbers from the database to update the dashboard. Right? But this has high latency, right? Because if you're okay with the daily update, then that's totally fine. And Presto gets popular because it queries large data set directly. And you can use Tableau to connect to Presto to do interactive analysis, which is quite popular. So again, coming back to the topic, which is building data, a data science or big data project, portfolio project. I think adding Athena or Presto into your project, it will be helpful. So I've seen a lot of data science portfolio projects, but I would say like 90% of them focus on machine learning, right? Running everything in a Jupyter notebook and interpret the modeling results. I think that's good. You can do Kaggle competitions as well. But if you want to have a big advantage, I think you need to show more skills. Because when you work in a data science team, you're collaborating with data engineers, data analysts, or if you work as a data scientist in a smaller organization or in a startup, um, you wear multiple hats. Like you're the data scientist slash data engineer slash data analyst. So sometimes you need to build dashboard as well, or even building dashboard to explain your machine learning model and do profilings. Or sometimes you're actually required to collect data yourself. So I think building something end to end instead of just the machine learning pipeline will be more interesting. So even just building a dashboard to explain your machine learning model, I think just that extra step is going to add a lot more value to your portfolio project. Okay, so um, Apache Kyling is an interesting project. There are equivalent tools out there as well, but in the big data world, uh, using Presto to query, your data warehouse or data lake, and of course it's convenient and you can do interactive analysis. But when your data is truly massive, when you want to join lots of big data, it doesn't mean Presto is going to make that happen in seconds, right? So pre-aggregation is always going to help you improve the performance. So this multi-dimensional OLAP concept is still useful in the Hadoop world, in the big data world, for example. So you can pre-aggregate data and load that into a NoSQL database. So and that allows it can help you significantly improve the latency, the performance of your dashboard. So the way it works is that this is an open source project, Kylie. It uses Hive so if you have batch data stored in Hadoop, then it will use Hive for let's say to read data from Hive, because Hive has the metadata information. But it does support like streaming data, whatever cubes update, like updating in real time, because data can come from Kafka. In terms of the computation engine, because you need to build OLAP cubes, right? So that involves some heavy lifting, joins and aggregation, and that is done using the MapReduce or Apache Spark. So you can use Hive to write the jobs to aggregate data, or you can use Apache Spark. And after you build OLAP, cubes. The cubes are stored in HBase by default, so it's a NoSQL database, and it has this, and then of course it supports the NC SQL, so you can use, Tableau to connect to Kyling to build your dashboard. So that's Apache Kyling if you're working in the BI space. Again, I bring this up here because I think it would be nice to have some kind of dashboard and BI component in your data science project as well, just to show that you have many different skills. And to be honest, we worked with a lot of students or career switchers, right? They want to become a data scientist, but the job market is pretty competitive. If you only focus on finding a data science job, then you need to have the right expectation. The market is really competitive. There are a lot of experienced people out there, so it may take you longer to get there, right? But are you going to wait 8 months, or are you going to just start sooner, right? So I guess my point here is that add some BI components, so it makes your resume or your more flexible, so you can potentially open up to BI roles as well. But because there are BI roles out there that requires advanced skills, Python, right? Maybe not so much machine learning. So you have to decide for yourself. But even as a data scientist, I think in real life, sometimes you still need to build dashboard. And AtScale is this commercial version of, I would say, Apache Kyling, but of course, it's much more, it has much more richer features. All right, so I think I only have a few more slides left. On the big data analytics side, from ML tooling perspective, and traditionally companies will use, banks, pharmaceutical companies, right, retailers. They're going to use SAS as their machine learning or predictive modeling engine. And companies are, starting to do more open source, so Python, R, and if you have really large data set, right? Many years ago, you might be using Mahout or MapReduce. And I've seen companies using Apache Pig to write their k-means clustering and logistic regression models, which is, I think, pretty cool. But it's definitely not the right way to do machine learning anymore. So definitely, if you have really large amounts of data, Spark ML or MLlib, right, are really great options. And of course, your companies will need to have a Spark cluster. But the good thing with running things in the cloud is that you don't need to have a permanent, Hadoop cluster. If you want to train machine learning at scale, let's say if you use Apache Airflow to automate the data pipeline, and your model training time is, let's say, 20 minutes, you can actually just spin up a EMR cluster and add that as a step in your ML pipeline or data pipeline. And it will start the EMR cluster, run the training jobs, and terminate the cluster just to save cost. So that's quite common approach to achieve cost saving. And of course, there are also companies that just purely rely on the SageMaker or Azure Machine Learning Services capabilities, right? Using SageMaker to label their data, build their ML pipelines, and coupled with like tools like Amazon Glue to run their Spark jobs for data manipulation, and of course use SageMaker to train models at scale and deploy an endpoint. So you can do that in SageMaker. And of course, there are companies that specialize more in the deep learning area. Then you can consider using TensorFlow, PyTorch. These are the most popular framework. So these are the ML tools, and oh, forgot to mention Kubeflow. So if your companies already have an Kubernetes cluster and running Kubeflow, if you can have your DevOps or the infrastructure team help you set up Kubeflow, then you can run your Jupyter notebooks, right, and run model pipelines and deploy models and serve models in the Kubernetes environment. I start to see more companies adopting.